Chromebook.
Right. So this section is kind of similar to what we've already been looking at. We were focused on finding our trig functions for different angles, and we were using the x, y, and r definition of everything, right? So that required you had an angle in standard position, so that means you had a point at the origin, initial side was on the positive x-axis, and terminal side ended somewhere else. And we would take the points x and y, we would find our r value, and we could do any trig values from there. So sometimes we're using those ratios to get our trig functions. We also, when I showed you that, I kind of talked about how we could draw a triangle and think of it as a triangle to do that, and that's going to be more of the emphasis in chapter 2. Instead of looking from standard position, we want to be able to look at a triangle and give the values of any of our trig functions from that triangle. So if you just have a triangle, first thing, this only works if it is a right triangle, so it has to have a 90-degree angle. If it does not, we cannot use these trig functions. Second, instead of using x, y, and r, we are going to use the SOHCAHTOA. Remember, I did show that to you back in chapter 1 as a trick for remembering those. So what did the SO tell us?
Sine equals opposite over hypotenuse.
Opposite over, yeah.
All right. What did the CA tell us?
Cosine is adjacent over hypotenuse.
And what was the TOA?
Tan is opposite over adjacent.
And we know if we have those, then we can get all of the others by doing the reciprocals. The reason this requires a right triangle, if you didn't have a right triangle, you wouldn't have a hypotenuse. And so then this definition doesn't apply at all. At the very end of the semester, we'll talk about what we could do in that scenario, but for now, we're just going to say it has to be a right triangle to do this. So if I had a right triangle, just a notation, typically we use uppercase letters for angles and lowercase letters for sides, and the side is always opposite the angle. So this would be like side A, this would be your side C, and this is your side B. We need to be very careful when we are giving the values of these. We have to have an angle to look from. If I said the sine from angle A, that's going to be different from the sine of angle B. And we could do either. So you have to include that angle. So from angle A, sine. So what's the opposite side? A. Opposite is across from it, not touching it. What's the hypotenuse on all of these? C. And that hypotenuse won't change. Hypotenuse is always across from the right angle. But what if I had asked for sine from angle B? What would happen? Side B would be the opposite side. So the opposite switches when you switch your angles. Could we do it from side C? No, because then we run into the opposite and hypotenuse become the same thing. So when we are doing these trig values, we can do it from either of the acute angles, not from the right angle. Okay, so I could only do it from angle A or angle B in this picture. And if we know sine, we automatically know cosec. Make sure you are remembering which ones are reciprocals. Okay, cosine from angle A. Cosine is adjacent. Adjacent is the side that's touching it, but not the hypotenuse. So that would be side over hypotenuse. So if we're viewing from angle A, this is the opposite. And then from angle A, this is the adjacent. And if we switch angles, then the opposite and adjacent flip. Okay, secant, reciprocal cosine would be C over B. Tangent, opposite over adjacent, and cotangent would be B over A. As before, these always have to be in lowest terms, so if you have any common factors, you need to reduce it. I don't like decimals. Radicals, make sure they are reduced as much as possible when you're going through here. All right, let's look at this. So, triangle ABC is a right triangle, and angle C is 90 degrees. So I know my right angle is C. These are A and B. If side A is 6, okay, where does side A go? Opposite of it. So it would go down here. And side C is the hypotenuse. That's 10. If I want the 6 trig functions, I need all 3 sides. How could I get my last side? X squared plus y squared equals r squared is what we've been using. If you're more comfortable using A, B's, and C's for a triangle, you can do that. It's all the same thing. In this, if we're just dealing with a triangle, your side would have to be a positive. So today we're not going to have any negative side values. Right, I want the 6 trig functions of angle A. So the sine of angle A would be, and that would reduce, so that means cosecant of angle A would be 5 over 3. Cosine from angle A, adjacent over hypotenuse, and reciprocal cosine is secant times 5/4. Okay, from angle A, I want a tangent opposite over adjacent would be 6 over 8. And so that means cotangent is 4/3. Alright, I want you guys to do the second example. It's with the same triangle, so you don't have to recreate that. But I'm asking for the 6 trig functions of angle B. So cosecant is cosine of B. And secant, tangent of B. And cotangent. Okay, look at this. We're getting the same ratios. The sine of A was the same as the cosine of B. Cosine of A was the same as sine of B. If we look cosecant of A and secant of B. Secant of A, cosecant B. Tangent and cotangent. So this is actually a property. When we switched to the other angle, all we did was flip the opposite and adjacent sides, right? So we get the same ratios, they're just assigned to different trig functions. That's what's called cofunctions. So you have to keep all this straight. We've talked about reciprocals, and that you have to remember. You have to know your reciprocals. But cofunctions have a different property. The cofunctions, when would sine be equal to cosine?
Whenever it's over or when cosine is over.
The triangle is the same, but you're finding a different angle.
Okay, so what's true about angles A and B?
The same.
they're not necessarily the same measure, but they are, what do they add up to? Three. Right, those, because we have a right triangle. So if angles A and B are complementary, if they add to 90, then the sine of one would equal the cosine of the other. So co-functions are equal for complementary. My pen just went crazy there. Kind of lost my place. Oh my goodness. I need to just slow down. You ever do that? You get interrupted in your thought process and you get back up to where you were.
The train actually derailed and crashed.
Okay, so sine and cosine are cofunctions. Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. So these cofunctions have the word co in front of them. Sine, cosine, tangent, cotangent, secant, cosecant. And what that means is they will be equal if their angles add up to 90. So if I'm looking at this one, secant and cosecant, I know those are cofunctions. So if they are equal to each other, what does that mean about their angles? They do not equal.
They equal 90.
They add up to 90. So this is a property, it's not necessarily difficult, it's easy to forget because it's not something we're going to use on a day-to-day basis, but I will bring it back up occasionally to remind you about it so we don't forget it. All right, I'm going to do a couple more examples and then we're going to look at something and that'll be our stopping point here. I want to find the 6 trig functions for a 30-degree angle.
That would be like sine 30.
So I actually gave you a triangle, a 30, 60, 90 triangle with those side measurements. Is anybody really curious where those side measurements came from? I didn't just make them up.
Sure.
I started with an equilateral triangle, which means all the sides are the same. Okay, and I did each of them having a side of 2. But we can only do trig functions if we have a right triangle. So you would have to drop your perpendicular. So that cuts the bottom side in half, so it's a 1. A hypotenuse stays as 2, and if you do Pythagorean theorem, your other side turned out to be 3. Radical 3. Alright, so what is the sine of 30 degrees?
Oh yeah, 1/2.
Opposite over hypotenuse, so 1/2. So that means cosecant of 30 degrees is 2. Cosine of 30.
Radical 3 over 2.
Secant of 30. If you flip it, 2 over the square root of 3, but that's not okay, so it's multiply, you get 2 radical 3 over 3. Tangent of 30. opposite over adjacent, but you can't leave radical on the bottom, so that's radical. So cotangent of 30 would be radical 3. And this is true for any 30, 60, 90 triangle. Okay, it doesn't matter what the side lengths are, because they would all be proportional. So if you know you have a 30, 60, 90 triangle, these ratios are always going to be the same. Let's look at 45.
Is it gonna be the one,
It would have to be 45, 90, and 5 degrees.
Okay. So if we want a 45, we have one angle that's a right angle and one that's 45. What's the other one turn out to be? Also 45. Okay, so if these angles are the same, these sides would have to be the same, so they could both be a 1. And if you did that, it would be square root of 2. Okay, does it matter which 45-degree angle I use? No. So let's say I start at the top one. So sine opposite over hypotenuse would be 1 over the square root of 2, which is radical 2 over 2. So cosecant, if you flip that, would be
Oh, we have to put degrees on that.
cosine adjacent over hypotenuse is also 1 over the square root of 2, which turns into radical 2 over 2. Reciprocal would be secant, so it would be radical 2. Tangent of 45. Opposite over adjacent, 1 over 1 is 1, so cotangent of 45 degrees is also 1. Alright, so what we've seen, we talked before in the last chapter about those quadrantal angles and how those are so important. We need to know those values and be able to figure them out. Well, it's also going to be true for the 30, 60, 90. We need to know those. Now, thankfully, that's the end of the values that we are going to have to learn. But this is kind of a lot. If I just told you you had to go home and memorize all those values, that would probably take a little bit of work. So I have some tricks to help us with that.
I thought it was the same thing, you just can't do it.
Okay, I have multiple ways to help remember these, but I have found that if I give you too many ways, it just gets confusing. So here's what I'm going to do. I'm going to teach my favorite way, the one most people like. If you really hate this, then come see me and I'll give you another method, okay? But I don't want to confuse everybody by saying you could do it like this, or you could do it like this, or you could do it like
Why
this.
is this guy's
That's a
fingers
lot.
pushed up against the glass?
Because that's what we do. Okay,
You can't do this like you.
so we're going to use our hand to model the angles that we need to know. The fingers are the important angles. So our thumb is going to be 0 degrees. And we're going to go up. The next one we're going to need is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. So, there is a pattern. For sine, it'll be the square root of the top over 2. Cosine is going to be the square root of the bottom over 2. And tangent is going to be the square root of the top over square root of the bottom. Let me show you what I mean by that. So if I said the sine of 0 degrees, you fold in your 0-degree finger. Sine is the square root of the top. How many fingers do I have above the one I folded in?
None.
None. So it's the square root of 0 divided by 2, which is, so the sine of 0 is 0. If I said the sine of 30 degrees, you would fold in your 30-degree finger. How many fingers do I have above that? 1. So the square root of 1 over 2 would be 1/2. Is that what we just wrote down for the sine of 30 degrees? Yeah. So there is a table underneath this you can kind of be filling out as we go along. So sine of 0 was 0, sine of 30 was 1/2. If I said 45, fold in your 45. Radical 2 over 2, and that doesn't reduce. The sine of 60, so if I fold in my 60, we have 3 fingers above, so that's radical 3 over 2. Okay, 90. Now, see if any of you are like me. I cannot fold in my pinky, so I have to fold mine in. I'm not capable of bending in my pinky.
What?
I don't know why. I can't.
It's because
So-
they're all connected.
How many fingers do I have above that one?
4.
So it's the square root of 4 divided by 2. 2 over 2, which is 1. So the sine of 90 is 1. Alright, is everybody okay with how we got sine? Okay, cosine. It's the same thing, but you're looking below. So cosine of 0, how many fingers do we have below? 4. So it's radical 4 over 2, which turns into 1. Okay. At 30. So cosine is the square root of the bottom over 2. How many fingers do we have below?
3.
So it's radical 3 over 2. 45. Cosine square root of the bottom over 2. How many fingers do we have below?
2 square root of 2 over 2.
60. Fold in your 60. How many fingers do we have below? So square root of 1 over 2, which is just 1/2. 90. How many fingers do you have below? 0. So square root of 0 divided by 2 is 0. Didn't I already tell you sine and cosine were cofunctions?
Oh, yeah.
So the sine of 0 equals the cosine of 90. The sine of 30 equals the cosine of 60. Sine of 45, cosine 45. So they're the same, just in
I was
reverse.
wondering why this chart looked weird. It's because it's not. It's in code, whatever. Instead.
Did I put it? Yeah.
I got really lost.
Okay, let's talk about tangent. Tangent square root of the top over square root of the bottom. So if I fold in my 0, I have the square root of 0 divided by the square root of 4. So 0 over 2 is 0. 30. I have the square root of 1 divided by the square root of 3.
1 radical 3 over 3.
1 over radical 3. So you multiply the radical.
Radical 3.
Tangent of 45. So we have 2 above, 2 below. Radical 2 divided by radical 2. 1. Tangent of 60. You have the square root of 3 divided by the square root of 1. And 90. I have the square root of 0, or 4 divided by the square root of 0, which is undefined. Is everyone understanding where I'm getting my values? So my hand trick gave us those 3. How could I get the others? Reciprocal. So let's talk about that. Cosecant is the reciprocal of sine. What's the reciprocal of 0?
Oh, yeah.
Okay, what's the reciprocal of 1/2?
2.
What would be the reciprocal of the square root of 2 over 2?
2 square root of 2 over. There's just a square root of 2.
What's the reciprocal of radical 3? the reciprocal of 1? Okay. Can you tell me 2 different ways I could get secant?
Doing the reciprocal of cosine and inversing the secant or whatever.
It's the reciprocal of cosine. So I could do the exact same thing I just did with sine. Or you could remember secant and cosecant are co-functions, right? So just like sine and cosine were the same but reversed, it would be the same, but the secant of 0 would be the cosecant of 90. So it's just this row backwards. Or you could go through and do the reciprocals of all your cosines. Okay. Cotangent is the reciprocal of tangent. What's the reciprocal of 0?
Undefined.
Reciprocal of radical 3 over 3?
3.
Reciprocal of 1?
1.
Reciprocal of radical 3?
Square root of 3 over 3.
Reciprocal of undefined.
0.
Isn't this the same thing as tangent but in reverse? Because they are also co-functions. Alright, you'll notice I have lots of copies of this table on the handouts I gave you. The back of this paper has a couple more. I think the first one I gave you had one on it. We're going to practice this a lot. Okay, this is going to be very useful as we move forward. That is my stopping point for today. I only have a little bit left, and I'll go through those examples tomorrow. So I will go ahead and give you all of the homework from the section. I would recommend getting started on some of it. Technically, you could do all of it right now, but we'll do a few more examples. Let's see. I might. Yeah, that's. So this is the whole thing. You could probably pretty easily go through at least like 37 if you wanted.